One of the greatest geniuses of our time, Stephen Hawking, revolutionized our understanding of the cosmos with theories that challenged the boundaries of physics. Author of A Brief History of Time, Hawking not only made us look at black holes in a new way, but he also left us a legacy of questions and warnings about the future of humanity. This video discusses one of those warnings, perhaps the most dramatic, the urgent need to consider leaving our home planet. But why would Hawking, a mind so brilliant and ahead of his time, advise us something as radical as leaving Earth? What did he see or calculate that many of us have yet to realize? Stay here and discover the reasons that led one of the greatest physicists in history to issue such a serious warning. The answer might not only surprise you, but also change the way you see our place in the universe. Stephen Hawking was not just a scientist. He was a visionary who pushed the boundaries of what we understand about the universe. Amid monumental contributions to theoretical physics and cosmology, he also harbored deep concerns about the future of humanity. Hawking warned that our time on Earth might be running out, not because of abstract theories, but because of very real threats he saw accumulating on the horizon. In one of Hawking's most impactful statements, he suggested that humanity might have only about 100 years to escape the planet. This leads us to ask, are we really taking this deadline seriously? Seeking a new home in the cosmos is not just an option, it may be a necessity. The threat of nuclear war remains one of the most serious risks to the survival of humanity. With the development and dissemination of nuclear weapons since the 20th century, the destructive potential of these weapons has grown to a point where a single armed conflict could not only cause immediate and catastrophic damage, but also trigger long-term effects on the environment and global health. One of the greatest dangers of nuclear war is the phenomenon known as nuclear winter, a theory that describes how soot and dust raised by nuclear explosions could block sunlight, resulting in a drastic drop in global temperatures. This could lead to catastrophic crop failures and widespread famine, affecting not just the countries directly involved in the conflict, but the entire planet. Moreover, the radiation released by nuclear weapons can contaminate extensive areas, making them uninhabitable for decades and causing severe public health problems, such as cancers and birth defects. Climate change also represents one of the biggest challenges to the sustainability of human life on Earth. Global warming, driven by increased emissions of greenhouse gases, is raising global temperatures at rates unprecedented in modern history. This phenomenon not only threatens to raise sea levels, submerging coastal cities and displacing millions of people, but also alters weather patterns, increasing the frequency and intensity of extreme events such as hurricanes, droughts, and heat waves. These extreme events have the potential to render vast areas of the planet inhospitable, directly affecting agriculture and the availability of fresh water, crucial for the maintenance of human life. Air pollution, another byproduct of the intensive use of fossil fuels, is already responsible for millions of premature deaths annually due to respiratory and cardiovascular diseases. Water pollution, which compromises entire ecosystems, also poses a direct threat to human well-being, affecting everything from the availability of drinking water to food security. Artificial intelligence is one of the most transformative technological forces of our time, offering significant advancements in fields such as medicine, economics, education, and more. However, along with its promises, AI also brings potentially serious risks that could challenge the very structure of human society. One of the main risks associated with artificial intelligence is uncontrolled automation. The replacement of human jobs by machines can lead to mass unemployment and increasing economic inequality. Additionally, poorly designed or flawed AI systems can make harmful decisions in critical areas such as criminal justice or resource management, with direct impacts on people's lives. Another significant concern is the development of autonomous weapons, which could decide to kill without human intervention, increasing the risks of conflicts and catastrophic errors. Stephen Hawking warned about these risks, emphasizing the importance of strict regulations and controls to ensure that AI development progresses in a safe and beneficial manner. the lack of a global ethical and safety framework could lead to scenarios where AI itself contributes to situations that threaten human survival, reinforcing the idea that managing AI is not just a technical issue, but deeply ethical and political. The idea of colonizing Mars has captured the imagination of humanity for decades. And recently, this futuristic vision has come closer to reality thanks to technological advances and growing interest from both governmental space agencies and private initiatives. Mars offers several characteristics that make it a viable candidate for colonization, not just in terms of proximity to Earth, but also because of its environmental conditions which, although challenging, present potential for human adaptation. The length of a day on Mars is very similar to that of Earth, with a Martian day being only about 40 minutes longer than a terrestrial day. This similarity could facilitate the adaptation of human biological rhythms to the new environment. Additionally, although extreme, the temperature variations are within a range that could be manageable with proper habitat technology. The Martian atmosphere, predominantly composed of carbon dioxide, with traces of nitrogen and argon, presents significant challenges for direct breathing, requiring life support systems for atmospheric conversion. However, the challenges do not stop there. The low gravity of Mars, about 38% of Earth's gravity, could have unknown long-term effects on human health, including bone and muscle issues. Moreover, protection against solar and cosmic radiation is a critical concern, as Mars does not have a global magnetic field or a dense atmosphere to provide natural protection like Earth. This would imply innovative solutions for constructing habitats that can protect future colonists from these threats. In terms of resources, Mars offers possibilities such as extracting water from the subsurface, which could be used both for human consumption and for the production of oxygen and rocket fuel through electrolysis processes. The ability to produce essential resources on-site would be crucial for the sustainability of a long-term colony, reducing the dependence on supplies sent from Earth, which is as costly as it is logistically complex. The icy moons of Jupiter, particularly Europa, have stood out as promising candidates for the search for life beyond Earth and even for future human colonies. Europa, one of the 4 major moons of Jupiter known as the Galilean moons, has a vast underground ocean hidden beneath a thick layer of ice. This ocean not only suggests the possibility of liquid water, but also of hydrothermal conditions that could be conducive to life, similar to environments found in the depths of Earth's oceans. The presence of a liquid ocean suggests that Europa may have a geothermal energy source, resulting from heating caused by tidal forces due to Jupiter's intense gravity. This internal heating could create aquatic environments rich in minerals and perhaps even warm enough to sustain life forms. If there is life on Europa, it would likely be microbial, possibly inhabiting near underwater hydrothermal vents, similar to extremophils on Earth who live in inhospitable conditions. From a human colonization perspective, conditions on the surface of Europa are extremely hostile. The Moon has a very thin atmosphere, composed mainly of oxygen, but insufficient for human respiration. Moreover, the radiation on Europa is intense due to its proximity to Jupiter's radiation belt, making the surface a dangerous place for humans without proper protection. Any colonization attempt would have to consider advanced radiation protection methods and ways to safely access the water resources below the ice layer. The technologies required for a colonization mission to Europa would involve not only vehicles capable of penetrating the ice layer and accessing the ocean below, but also advanced life support systems able to function in extreme conditions of cold and radiation. Additionally, it would be essential to develop robust techniques for water extraction and purification, as well as on-site energy production, to ensure the long-term sustainability of the colony. However, transforming these distant worlds into homes requires more than just willpower. It requires technological advancements that are still under development. The journey to Mars, for example, which spans about 140 million miles, demands space transportation technology far beyond what we have today. And survival in these hostile environments requires innovations in bioengineering, habitat construction, and life support systems. as we explore the possibility of establishing colonies beyond Earth. Education and research are crucial for this bold leap into space. It is no longer enough to learn only about our own planet. Now, we need to understand entire planetary systems, extraterrestrial ecosystems, and the principles of life in inhospitable environments. Investing in science and technology means not only funding these studies, but also inspiring future generations to dream big and pursue careers that will shape the future of humanity in space. Furthermore, international collaboration will be key to the success of space colonization. The conquest of space cannot be a competitive race, but must be a cooperative effort that transcends borders, cultures, and ideologies. In joint projects like the International Space Station, which brings together more than 15 countries, we can see that global cooperation is not only possible, but already in practice. But can we expand these partnerships to not only share the burden, but also the benefits of a new home in the cosmos? Each of us has the capacity to contribute significantly to this audacious space colonization project, whether by gaining knowledge and expertise in areas such as astrophysics, space engineering, or sustainability, or even by supporting policies that promote scientific advancement and environmental conservation. Your actions can propel humanity towards a new horizon. Once, Hawking said, "We should look up at the stars and not down at our feet." This thought is not just an exhortation to explore the universe, but also a reminder to dream big and seek a greater purpose. If this video has piqued your curiosity or inspired you in any way, don't forget to like it and share it with your friends. We want to hear your opinion. Do you think humanity should start seriously planning the colonization of other planets? Subscribe to the channel for more intriguing discussions like this one, and comment below your ideas or questions about the possibility of leaving Earth. Your interaction is essential for us to continue exploring these important themes. Thank you for being part of this community.